Now let's talk about a couple of important concepts in the flip-flop functionality, and especially we call it a timing constraint. And if you are going to interview with some companies which does some digital design along with the software, uh, they may ask you this basic concept around the flip-flop. Uh, so there is three things: setup, setup time, hold time, and clock to queue delay. What are they? So far, we have kind of envisioned ourselves D. We can change the value till uh, your clock is goes into 1. After that, we need to make it stable and so on and so forth. Uh, but there is a minimum time defined from the clock from the flop behavior that your input D must be set, okay, before that time. Okay, for example, here let's say clock is coming at these time points. Okay, now what the setup time says is that your D input data, that signal, should be stable a minimum time before the clock goes to 1. Okay, so here I am trying to get a 0 from D to the Q side. Okay, the Q side, let's see, it was 1, I want to make it 0, and so on and so forth. So D I must set to 0 so that next clock cycle your Q output of the flop become 0 from 1. So I cannot do it arbitrarily close to the clock goes high, or at the same time as the clock goes high. I cannot just make the D goes to 0 when at the same time when clock goes to high. I need to do it a minimum time before the clock goes to high. I need to make the D 0 a minimum time. Okay, I can do it before, way before that time point, but there is a minimum time bound from the rising transition of the clock to set the D values to 0, and that time is called a setup time. So this is the minimum time before the clock goes to 1. Okay, when my input data needs to be stable. Okay, I cannot change the data after that time point, after this time point. Okay, in order to like flop to successfully latch this data and put it on the queue. And there is a hold time, like I cannot change the arbitrary time as soon as the clock goes high and I think, okay, this is latched, I can change it. I cannot. There is a minimum time period, minimum time value with respect to the clock rising edge. Uh, Assuming, of course, there is an assumption here. Assume this clock is a positive edge triggered clock, and all this discussion definition I'm doing with respect to a positive edge trigger clock. If it was negative edge trigger, then we'll be discussing the same concept around the negative edge of the clock signal. So hold time is the minimum amount of time through which you need to hold the data stable at the D input, okay, after the clock rise transition. So that's my T hold. So that means I need to make the D available before the T setup time, that setup time before the clock rise, and I need to hold on to that value till a hold time after the clock transition happens. Okay, this is the period of no change from D as a logic value. We cannot change it. If we can change it like before and after, etc., but that may or may not reflect onto the queue. So this is my setup and hold time. This is always respect to the input pin of a flip flop. Now clock to queue delay. Okay, So this delay is from the clock active edge, so in this case it is the positive edge of the clock, till my Q get changed. Okay, till my Q gets changed, that's my TC2Q, that clock to Q delay. So as soon as this clock goes up, things doesn't get into my output. Okay, not for the flop, not for the latch. Okay, it has a delay around it. Okay, so not so it has a minimum delay that from which your new data will be reflected onto the queue. So that time is your clock to queue delay. Okay, that's just couple of definitions. These are very important in the digital design area, and lot of checks analysis is done around this concept, whether signals or incoming signals are meeting the setup time, hold time, and so on and so forth. And of course this clock to queue delay will impact the down the line, like next stages of the logic gets setup and hold time, it will affect that. So that's another important concept here. But for you guys, like, these are the definitions, that's all you need to remember, that too for interview if you go in certain companies which deals with digital design. Okay.